Hi, this is Mohammad Shahbaz Akhtar. Today is Sunday and the date is I'm recording this tutorial for demonstration of Universal Max Bit protocol in order to solve the generalized control flow problem on 7 November 2021. It is very nice protocol used for that can solve the max fit problem of multiple type of traffic like unicast, broadcast, anycast, multicast, and we will see this for wired network later on in the upcoming tutorial. I will demonstrate how it works on wireless as well. So firstly, before going into the detail, firstly I will give you an overview about Omnet++ simulator. If you have not installed in your system, then you can do it from here. Let's go to this website, open the browser and type Omnet++. This is a discrete event simulator. Here you can see the multiple things there. I'm using the 5 point, go to the download. I'm using this version of this Windows and go to the older version. I'm using 5.6.2. okay, but at the time of recording this video 5.7 is also available, so it doesn't matter which version you are using. All you can do in all the version. And so if here choose your operating system, it is Windows and 685, and then download. I have already downloaded, so I will not download again. And after downloading you have to install it. For installation purpose, you can go to the demo documentation. Here you can see the installation guide. In the documentation section you can see there is an install guide. Open it, and here you will see for different type of platform how you can install, like for Mac, Linux, Ubuntu and Windows. To go to this Windows, here they have given a detail. It will take some time and it is a little bit tricky to install, so you have to go to this document in order to install this software, because it requires a large number of packages to be installed on your system and a large number of compilers is required. So multiple compilers are required, so you have to go to this document in order to install your Omnet++. After installation, one more document you may download as for your reference, which is simulation manual. Here is this one. So it's very good manual. You can go through this manual for different type of references required while understanding or implementing any protocol, like how it is modeling, how it is message communicate with the gate, what is simple modules, how we make a compound modules, how the message sending and broadcasting, all the details are given in detail. So you may refer this document for your any help. So after installation, you can find your installation file here, documents. You have to go to this PC, then you may go to documents, and here you can see there is an Omnet. This is the version 5.6.2. you have to double click on this one, and in order to start the simulator, you have to choose this one, this command prompt. Here you have to write okay, yeah, now you can write Omnet pp in order to start the simulator, and press the enter. Starting the IDE, so it is starting. Till it is starting, I will suggest you that you make a workspace as a separate window, because if you don't make a separate window folder of your workspace, all the folder will be saved here, samples. So already you can see there is a multiple projects that is saved here. So it is better if you make a workspace where you put your all of the project together. So like here we have UMW implementation, we have BP back pressure protocol implementation, and different other projects are available there. So I prefer to make a different folder because sometimes Omnet++ may crash. So if it happens and you have to reinstall it, all the samples folder will be overwritten. So it is better if you make a separate folder for your workspace. So it is open. Okay, so after starting the IDE, it will ask you about the workspace. You can see I'm using this location, C user document Omnet IIT Madras project space. This is my workspace. Or if you have you may have different workspace. So in my case, it is IIT Madras project workspace. So let's launch this one. Okay, here is it. So this is our folder. In the let's open it. You can see there is multiple files are available here in the folder. All others are the different different projects. So we are interested in UMW implementation. You can see there is a binaries of it is not created by the user. It is by default when you run your project, it will create it. Includes also is not a part of the user defined folder. It is so only you can see there is this is a result folder. So I will illustrate how you can design it, because we require a wired network, a random wired network which is connected with each other. And so firstly we have to define the modules, simple modules. Simple module is nothing but it can be a router, it can be a switch, it can be a user, so it may be anything. So simple modules is defined, or a component modules is defined with NED language. So firstly you have to make a NED file. So I have already made some NED file in order to go to the node. In the node you can see there is a routing.ned extension of the module is .ned, routing, node NED, queue NED, application NED, then and these are the different C++ coding of this implementation of this module. So firstly go by one. Each node of in this implementation, let's open it. Node.ned is a compound module. You can see that this is the node, where you can see the multiple simple modules are there, like app.ned. Here is app.ned. There is a routing.ned. There is a routing.ned. Here is it, and there is a queue which is lq.ned. So all these three different simple modules make a compound modules, which is called, named it as a node. So here you can see that this is a module node, where we have defined the properties of this compound module. So before going to the compound module, let's see what is there in the simple module. Firstly, there is app. Okay, let's open this one, app. This is the design part of this. This is the icon. You can edit from, like if you the right click here, the properties, then you may change the appearance of this icon. So appearance is very depends on your personal choice. Now if you go to the source of this file, you can see that we have package.ned. that is package.ned is nothing but there is a package.ned here, ned file. You have to include this one. So package node is that we are using this node folder. That means this app.ned is defined in this folder, that is package. If it is in the networks folder, you may have to write package networks. Okay, and so if we want to make a collection of NAD files, we can do it by making a folder, and you can call this folder or include this folder by the word package NAD. So you can see that we have define a simple module, simple app. There is a parameter. The module may have different parameters, like it can accept different types of parameter type, like it may accept integer, string, and double value. Multiple things that can take. And here you can see that we have the two gates. One is input gate, one is output gate. App.nad is nothing but our source. It will generate our traffic. Okay, so you can see that it has one output gate and one input gate. So I can show you here. This app.nad. You can see that is a it is a link, and here the link shows the routing dot local out, that is routing have a gate which is named as a local out, is going to as a input to app dot n in. N is the input gate of this app NAD. So you can see the name of the gates. It is a input in, output out. So it is had one single input gate and single output gate. Both of the gates are have different. In the Omnet Plus we can have a in out gate also, that can the single link can take all the input output with each other. So but in this case we have two gates only, input in, output in, out. These are the different parameters we have defined, because int address it will store the address of the node, like node 0, node 1, node 2. If we have 15 node, so then because after defining this NAD we make a network, and all the network will compose of the different types, different number of app NAD, because we will not define separately each of the app NAD or source NAD for each of the node. Here we have to define only one times, and we can use it for all the other purposes. So it can store the int address, it will store the destination address. It will also have volatile represents that each time if it is called, it will give a random value. So volatile send unit, it is the time between the generating packets. If it is 0.1, it means that in 1 second it is generating 10, it will generate 10 packets. If it is 0.01, it will generate second, then it will generate 100 packets, because 1 by 0.1 means 10 packets per second. That means 0.1 second it will generate 1 packet. In 1 second it will generate 10 packets. Similarly, we can change the load factor from here. That and if you especially not provide any value, so it will by default it will take this value. Then is the int packet length, the packet which is generated. What is length it will hold, it can store this value. This is the display part, is the representation of this module. Now we in order to get our in order to store our result, we have to use this keyword at signal end-to-end delay, because this is a source, and it make you can tell it as considered as a user. So it can either send the packet or it will receive the packet. So when it will receive a packet, it will take the end-to-end delay value of that packet and will store, so that after analysis, when you want to take a result, you can make it you can process that information for your different purposes. It will also hold the hop count of the received packet. Okay, so this is a type of that variable, that end-to-end delay will have the unit of second, and same time it is the data type of Omnet ++, where this represents the same time as simulation time, and unit is second, and the hop count will be the long value, data type is a long. Now it is another word keyword is a statistic. That means you have received end-to-end delay of a packet, but what you want to do with that end-to-end delay value. So firstly, there is a title, end-to-end delay of the error packets, unit is the second. Record what we want to record, the mean of that packet, max of that packet. Okay, now for hop count, what we are recording in for our purpose is the mean and max. Okay, so all this is the source, this is the source part of your node. Now let's move to the second part, which is the routing part. One more thing is that this is the NAD language. Okay, the other properties of the complete properties, how these parameters are used, is implemented with in C++, and app.ccc is the file where we have let's click here, we have this. You can see that there is a multiple information is defined about the packet. Okay, now let's move to another NAD file. This is a routing.NAD. So let's go to the routing.NAD. You can see there is a different icon. You can change it from your making the right click and properties. Now you can see the source. Here also we have to give the package node, because this NAD file is existing in the node folder. So the simple routing represent is we are defining a simple modules, because collection of simple modules make a compound module. So we are defining first the simple module. So it has there is no such parameters, although these are all the parameters, but for result purpose I have commented it. You can comment by double backslash and again uncomment by remove that one. So it is a routing module. It is the main module responsible for all types of routing purposes. Routing decision is taken here, that where to forward the packet, where how to store, and where to go. All the decisions are implemented in this simple modules. It has, you can see that they have multiple gates: input in, output out. You can see there is a bracket here which represent it is an array. That means we have multiple input ports and multiple output ports, and there is will some index like input in a bracket. If there is an index like 1 2 3, that means it represents the index number of that array gate. You can see that there is other two input output gates. It is a single input gate, local in name, and output gate, local out gate. Okay, so it has total, you can say that you have a total two gates, one input, one output, which is single gate, and two array gates like n number of input gate with named in, and n number of output gate is represented by out. In the bracket there will be some index. So it is all about the definition of this routing NAD. Now let's move to another route NAD file, which is the queue. So here is the LQ. Okay, so here is also you can see that there is a package node is there, and this is also a simple module. Now let's see what are the parameters I have defined here. Int frame capacity, it represents actually the how much since we are making a queue, so queue may have a finite capacity, frame capacity, so it represents that it can hold up to 1000 of packets. If at a particular time our number of packets in the buffer is more, already 1000, and some other packets come, so it will drop that packet. So it is we can manually define the frame capacity. If we remove it and make it default in the bracket 0, that means it has infinite capacity. So you may, depending upon your requirement, you can define here the value. Otherwise, the link capacity, that means one node is connected to another node by a link. So what is the link capacity? Because in UMW the capacity of a link is represented by number of packets per second that can be transferred through the link. Another one is the use cut through switching. By default it is not false. I will explain it later what is this. Then there is a display. This is the keyword is used to represent the icon, and we have used this icon. So this one, and then another one is the this is a keyword signal keyword used when you want to do any recording or any information you want to store while your simulation is going on. So what type of information we want to record for our analysis purpose? There is a queue length. What is the queue length? Queue length, and the queue length is defined here from the statistics queue length. The title is it is a property which we want to record. The title is queue length. Recording with time, we want to record the time average, max value of the queue length, mean value of the queue length. Another one is the queuing time, that you can see also the unit, like for queue length it is the type is long data type. For queuing time is represented by simulation time second. So the queuing time is here by defined as statistics. Queuing time title is this one, queuing time at the queue. A unit is second. A record what type of information you want to record, time average, max, mean. Another is the drop. How much packet drop is there, because when you are defining a finite buffer capacity of a queue, so it may be possible that some packets may be dropped. So I want to record that value also. So here also we have defined a signal, name it as a drop, and the data defined the data as long. So you can see that in the statistics it records the drop, and the title is the drop packet in byte. Unit is bytes, and so here is the unit was a second, there is the unit is bytes, and what we want to record the count, that is number, and the sum, that means suppose that each packet has different may have different size, so we want to record the size of the packet which is dropped. Like if we have 100 byte of size of each packet, and we are 10 packets have been dropped, so 100 to 10 will be 1000 byte is the value of the sum. So, and also we can see there is a 3 gates here, that is input in, output out, in out line. Okay, so these are the 3 different gates here. It is defined. You can see that in input out, input in, as I have already explained, it represents a single input gate whose name is in. It represents single output gate by out. In out means there is a single line, single link, but it can be simultaneously take the packets and send the packet via the same link. So you can see that the app NAD has input output gate, single input single output gate. Routing NAD has 4 type of gate, 1 single input gate, 1 single output gate, and 2 the gate array is there. And for Q is we have 3 different gates. There is no array gate here. So how we make a compound module via using this topology? So that is done in node.nad, because node is a compound module and we have to connect this one. How it is connected? Let's see how it is connected. So okay, where we are, okay, we want to define make a compound module by using these 3 simple modules. So this is our connection type. So you can see that this one, we go to the source, and here is that the package node, because it is the node.nad is also defined in the node folder. So package node. So in place of simple, now we are using module, because we are defining compound module, not simple module. So what are the, you can, in the compound module you can also define the parameters name, like int address. It will also hold the value of link capacity, string, app type, what is the type of source we are using. This one you can, it's on hold, or this represent the icon type of our node. So it has only 1 gates in the, because compound module one compound module need to communicate with another compound module. So compound module also need some gate in order to make a connection. This gate will be connected to the more than one of simple module in order to share some information. So it has only 1 gate which name is port. It is an array gate and in out gate. That means port it may have n number of gate, because it is an array gate, and all the gate is in out type. That means simultaneously we can send, and all the information, incoming and outgoing information, will go via the same gate. Now we have to make include our simple modules here. So first simple module is our app. So app colon and app type. Okay, it is defined and is the parameters, that because you can see that address is the parameter of this node, and also there is one address parameter defined in the app entity. You can see that there is one parameter given address. So what we are sharing information is that when we have some address value stored in the address in this app NAD, that value will be copied to compound module. That means if you are saying that a node 0 have the address 0, so this value if is passed to this app NAD, it will copy to the compound module as well. So this one, and this is the display type of our icon, which is of the app type. Then we want to make a routing. You can see there is a small letter, and this is a capital letter, because our module is defined as the routing.nad. It is single time it is defined, but when we want to make use it for our multiple purposes, you have to you can, in place of routing, you can give another name also. That will be that name will be represented. You can see that in the routing there is a small r. So it is the basic how we are inheriting our NAD file to make a compound module. That there is a routing NAD available in the folder. Now we are inheriting this when renaming this NAD. All the properties will be the similar, all the gates will be the similar, but its name will be different, in order to make a differentiation between the different types of routing module with each other. So there is the icon type, and you can see there is a gates. You can see the already routing and have in input gate, output gate, this type of gate are available. So in routing in node.nad, you can see that now we have defined the size of this array, because in routing.nad you can see it is kept blank, that it is the size will allocate dynamically. So we want to now allocate the size. So the size defined here in is size of the port. Out size is, it is a keyword. So port is our this array type. So we are saying that whatever the size of this array will be the same as that of routing .nad. That is, if suppose that the size this port in out gate have 10 array 10 number of gates, so that 10 number of gates will be 10 input gate in output gate of this routing.nad. Now it's we are copying the L2Q. L2Q is defined as NAD file, like it is a Q module, and we are renaming it to be Q, a small q. You can see that a small q, size of the port, a small q, size of the port. Here also the size of the gate number of q which is available is depends upon the array value of the port. Basically the port is the link, that means if it is connected, it is the link, because it is the gate of the compound module represented by port. So if it is connected to 5 different node neighboring node, so the value of this port will be 5. So this there will be 5 q will be here dynamically allocated here, although it is represented by single, but it's at the final I will show you a final diagram that it will have multiple number of queues will be there depending upon connection to the neighboring node. It is this simple module is dynamically allocated at the runtime. So the size of that the number of queue is basically the size of the port. And here also we copy the link capacity. The link capacity is the parameter available in both this folder, that node component module, as well as the simple module of the L2Q. So we are copying this value to providing this value to compound module as well. Let's see how it is connected. You can see that firstly start with the app.any. This one, the app is connected to the routing. App.out, that represent there is an output gate, is going as a routing.local in, and because routing have also you can see there is a local in input gate. So one output gate of app is going to the input gate of local in. So that is why it is written app.out local. Similarly, the output port of the routing NAD is whose name is local out is going to the input gate of app.in. So you can see that there is a one single two link is there. You can see the two different direction. One output link, one gate is connected to from routing to app, and one gate is connected from app to. And if you move cursor to this link, you can see that routing.local out is going to app n. So this connection is done. Now how routing and queue is connected, since we have dynamic number, we may have n number of queue, so we need this link to be n number. So that way there is a circular is given here that represent this link is not a single link, it is a dynamical link. The actual number of link will be defined in at the runtime. So how it is connected now? So this one is done. For we are making a loop for I going to size of the port -1, because the array index will start from the 0. Whatever the value of port is obtained is provided is really available at the runtime. So here you cannot say that what is the value of the port. So whatever the port, suppose it is the 10 value is 10. So 0 to 9, it will go from 0 to 9. The routing.out it is the index 0 1 2 3 4 is going to q number of and q index is represent the q module, simple module to in. So routing dot out is going to q in, routing dot out is going to q dot in. Similarly, routing dot in, route q index I dot out is going to routing dot in index I. So here both connections have been done. Now we have to make one more connection to the, because this is a compound module, so we have to make we have to communicate to the outside of this module. So for this we are doing what we are doing, qi dot line is connected to port I. Port I is the gate of this compound module. So we are connecting the gate of compound module with the gate of the queue, because the queue is the outer part of our simple module. So it is connected here. So all the connection have been done, and all the different simple modules have been included in this compound module. So connection part is done. Now we have to make a network, because it is a compound module, and a group of simple module make a compound module, and a group of compound module will make a network with a connection with each other. So for this I have defined our network in here, routing random graph.nd. We have multiple, I have defined multiple number of network for our UMD implementation. I am using this one, random graph.nd. This is also an ND file. Here you can see package networks, because this NAD file is defined in the network folder. So you can see the package network, and it is the graphical representation of the network. You can see that there is a node, n number of node with bracket index is n, because n is a dynamic value. We have to provide input value, we have to provide this value in order to make the network according to our requirement. So is the source code. So we have to include this package networks. We are saying that this NAD file is defined in package networks. We have to also include the node dot node. That means there is one folder node, a small node, dot node, capital node. We have to include this one, this node here. And also one more simple module is there, which is node dot network topo info, node dot network topo info. Okay, this one. Okay, so you can see we have imported two different NAD files. One is this node NAD, because it is a compound module, and for our network purpose we only require the compound module. And we have also imported network topo info. It is another NAD file. Actually I skipped to explain what is network topo info. Actually it is a controller. So you can see in the main random graph this is a node, is a compound module. It is a network controller. So network controller, it don't have any gates. It has only two parameters, packet length and link capacity. Because anytime when I will explain how it is implemented, you can see that all the node will have to communicate with network controller in order to get their make the routing table. So it is another NAD file is here is there. So for the final graph, which is defined in graph.nad, we have both simple module and compound module node, and the simple module network topo info. So now for simple module we are using the keyword simple. For compound module we are using the keyword module, and for making network we are using the keyword network. It represents that now we are making a network. Name of the network will be the random graph. You can see the name of the network is random graph. If we change this value to like make random graph 2, so you can see random graph 2 will be there. So whatever you will edit here, it will be reflected here also. So now these are the network have different parameters also, because it is also an NAD file. Int n prompt, enter the number of nodes. It is an input parameter. We have to provide it as an input. So if we want to make a network of 20 nodes, we can give the value to where we have to give this value. I will explain later. Int n prompt. It has also three different parameters, like link capacity, like how all the nodes are connected to each other via link, and what is the capacity of that link. It is also input parameter. Packet length, It is also an input parameter that the packet which we are injecting to the network, what is this its size, and it is the degree of connectivity, because we are making a random graph, so it represents how much percentage of connectivity we are required. Its value will go from 0 to 1 maximum. If it is 1, then it is a completely connected network, is a mesh network. So this is the parameter that is defined. Now it is the types. So we had manually defined a channel whose name is packet per second. That represent it is already defined channel is the data rate channel. We are extending that one. So where we have defined the data rate of the link capacity. It is represent, it is a whatever the value you will provide, like link capacity, packet length capacity, into it will be the capacity of the channel. Now since it is a network, we have to make include also the simple modules. So simple modules we have defined here is a network controller, because network topo info is the NAD file, but now we are inheriting this NAD file to our network, so we have changed this name to network controller, because you can see there is its name is network controller. If we make it to be network controller 2, you can see its name is changed to 2. So it is inheriting the network topo info NAD file, but its name may be as per the user choice. Also this simple module network controller have require two information: the packet length and link capacity. Packet length, link capacity is will be copied from this value. You can see there is a input parameter we will provide as an input to this as input to this network, and that value will be copied to our here simple module, because simple module have two different parameters. You can see that network topo info have two parameters: packet length and link capacity. That value is copied to this one, whatever we will provide as an input. Now one simple module have been defined. Now we are inheriting node. Node is an NAD file, and we may want to make n number of node. So all the node will be similar to each other, but only difference will be its address, like index value. So node and here n is the input parameter. You can see we have n, whatever the provide, like if we provide n is equal to 10, there is the 10 node will be generated, because it is a node array, and all the 10 nodes will have the similar properties of that node NAD. So node NAD is a compound module. It has also, we have already defined some parameters. So now we are giving the value up to this parameter, like whatever we provide link capacity of node, like link capacity of node, it will be provided to the compound module link capacity. Also the index, that means if it is node 5, then index will be 5. So that index will be provided as will copy to address. Address is the parameter of node NAD. You can see here. You can see there is address parameter. So whatever the index of that node will be copied to this parameter of the node NAD. Now another one is gates. How many gates of this graph network have? It depends upon the input parameters, like number of nodes. Suppose that if we have 10 node, so it may have maximum up to 10 node. However, all the gates may not be connected to each other. So this n value is for user input value, and depending on this value we can define the gates of this node NAD, because node NAD have one gate which is named as port. You can see here there is one gate, in-out gate port. Here we have not provided the value of actual value of this array. So here we are giving the actual value, user defined value. So now since it is a random graph, we have to suppose that user have provided 0.5 degree of connectivity. There is 50% of connection. So you can see how it is connected. For I is equal to 0, n minus 2. And for we have making two different loops for j plus 1 n minus 1. You can see that the node I dot port is the is a gate number of that node. I is equal to 0, j is equal to 1 is connected via it is a channel name. Packet per second is a channel type is defined. Is connected via with a channel with a link having this property, his capacity property, direct property, to the node j, and it is the gate number of that node. if this condition is satisfied, so it will make our random graph. So how now I will show you how we make a how it is working. So since you can see that we have defined different types of NAD, like app NAD, routing.NAD, queue.NAD, network topo info.NAD, random node.NAD, and random graph.NAD. All you can see that we have total 6 NAD files is there. We have already defined the property of all of these NAD file, how the gates are there, how it is connected. Now let's see how what are the different parameters which we have provided, how it is working, how it is going on. Okay, let's start. Actually there was short little break. So you can see that we have total 6 number of NAD files. So how we are providing input to this NAD files? There are two different ways. Whether you may define here, like if int is equal to something value, you can give it. But this keyword prompt is used when it is if you user want to if the simulator will ask to the user to provide that value. So either you can define here all these value, or we have to define an initialization file. You can see the .ini file here. When double click here, we have to actually this initialization file can store the detail of multiple network. Like you can see that here we have different type of network, dynamic.nad. So all we have this keyword, we have to use config, then there's a network name. So let's go to I have defined different parameters for different type of network. Let's go to our network, that is config random graph. It is the name of that our network. So here you have to give that this define network. One second, there is one call. So you can see that I have defined here the number of nodes to be 20. You can also, if you remove this one here, you have to comment by giving the hash. If you remove the hash, then you can uncomment this value and this line. So okay, so like if make it like ask, then the runtime it will ask you the value. So for now I make it comment and give a manual value like 10. Okay, now this is all the parameters we have defined. That is that random the network name dot link capacity node, that is 100 the capacity of the link is 100 packets per second, and is the capacity of is a packet length of generated packet, and is a degree of connectivity. All the value we have to give random dot to inform the simulator that we are defining the parameter of which NAD file. So since we have the random graph and these are the parameters, we are defining here with the INF file. So degree of connectivity is 0.5. So now let's run it. You save it, and you can go to here. So here you can give the simulation time, how much it is. By default it is set to be 600 second. Now also here the this represent the packet generation rate. It is generating 500 packets per second. For now we make it to 0.1, that is 100 packet per second. So now let's run this one. Here they're asking for the network name. So okay, one second, I have to comment this one and comment this one. Okay, now it's fine. you can see we have make the number of nodes to be 10, so 0 to 9. You can see the 0 1 2 3 4 5 6. Now if we remove this one and make it ask, then they will ask you the value, like enter the number of nodes. Here you can give any value, like 15. So it will generate 15 a random network with 15 number of nodes. Now this connection is a random connection. So let's see for 10 nodes, and let's see if we make it to be 1. There is a complete mesh network. You can see here also, if you give the ask value, then you can see that it will ask you the degree of connectivity. You can see there is a complete mesh network. And if you make it to be 0.1, you can see the degree of connectivity is now reduced to a very large extent. So it is a variable, and for the result purpose I will explain how I have used this one to get our different type of result. To make it 0.5. Also one more thing is I will show the internal architecture. Like for 6 node, I make it to 6 and 0.6. How it is connected. So you can see there is a 6 node is there, 0 to 5, and this is a network controller. Is a simple module. These are the 6 compound module, that is node. And since we have provided input as n equal to 6, then 0 to 5 is the index of each of the node. Now if we make the cursor here and then right click here, view graphical view. This is the graphical view. You can see there node 0. It is the random graph.node 0. It is the app, one simple module, then routing, another simple module. Since I have already told you that these are dynamically, these queue are defined. Since we have 6 node, 6 queue have been defined, because for mesh network it will be connected to 6 different number. It will have 6 different links to other nodes. So it is defined from 0 to 1, 0 to n-1 for each of the link. Although all of the link may not be active at the same time, because since suppose the node 0 is connected to node 1 and node 2, so already Q1 and Q2 will be connected, will be used, and other Q will remain unconnected, unused. This is the internal, it is defined. So if you can see, if I start generating the packet, you can see 0 is to 0, 0 to, it is generating packet from 0 to 0, 2 to 1. 2 to 1 is gone through this one, you can see. Okay, so this is the internal architecture. Like for node 3 graphical view, you can see there is a node 3 connected to 4, 5 and 1. So only 1, 4 and 5 queue will be active, and remaining other queue will be will remain unconnected. Okay, so this is for today. We have I have given you the very fundamental detail of Omnet Plus installation, and what are the documents you may need to refer, and also I have told you about the for Omnet Plus implementation, what are the different NAD files I have defined and how it is connected, what is a simple module, what is the compound modules, and how we make a node of, and we make a array of compound module, and how we are defining our random network by using a different degree of connectivity option. So this is for NAD. Now since we have defined the NAD file, now we have to impose its properties. So for each of the NAD file, you have to make a C++ file, supporting file, that will define. From there you can the implementation is there. So today's video is already going to be of 50 minutes. So in the next video, in the next tutorial, I will explain each of the NAD file, simple module, and how it is implemented in C++. Till then, bye. Okay.